So the goal here is to try to figure out how many atoms are in 4.5 moles of a sample of helium. So 4.5 moles of a sample of helium. And it actually doesn't matter what the element is at this point, because if you have 4.5 moles of something, you'll have the same number of atoms regardless of what that something is. It just might take up more space or something like that. The best way to do these kinds of problems is when you're starting off, sometimes it's easier to think of moles as like a dozen, because you're familiar with dozen and 12 and its association with the number 12. So if I had 4.5 dozen helium atoms, then essentially what I would do is I would try to make some kind of fraction. Now this equals sign can make two fractions. It can have either the dozen on top, so you have 1 dozen over 12 things, or the dozen on the bottom, so you can have 12 things over 1 dozen. You can do that by basically taking this equals sign right here and dividing both sides by 1 dozen. And in that case, you would have on the left side, that would equal 1. And then you have 12 things over 1 dozen. Or you could divide both sides by 12 things, and you would end up getting this top fraction. Now, the question is, which fraction do you use? And the answer is, you use the fraction that the units of the denominator is probably one of the most important keys to this trick. Is you look at the units on the denominator of the fraction that you're looking for, and you want it to cancel out with the units of the numerator from the thing you're multiplying it by. So I'm going to have a fraction here, and which fraction do I use? Am I going to use the one with the dozens on the bottom, or the things on the bottom and dozens on top? And in my case, I'm going to choose the one with the dozens on the bottom, because over here I have dozens on top. So I have 4.5 dozen of something is 1 dozen on the bottom and 12 things on top, or heliums, or whatever you want to call it. So 4.5 times 12, that's going to equal to, shoot, I guess I should have done this beforehand. That would be 48 plus another 6. That would be 54. Yeah, 54. 54 things. Now, that is not as hard because you use two things with dozen. Well, essentially a mole and the associated number 6.002 or 022 times 10 to the 23rd power is the same concept as a dozen. We're just dealing with a lot bigger numbers here. So 1 mole equaling 6.022 times 10 to the 23rd power of things implies I can have two fractions. I can either have the 1 mole on top divided by 6.022 times 10 to the 23rd power things. And I don't need that. Things doesn't need to be the word things. It can actually be atoms or molecules or marshmallows or whatever you want to call it, because you have, just like you don't need a dozenness doesn't always need to talk about eggs. It could be talking about donuts, which actually for me is something I'd probably prefer. Or the other fraction you can have is the 6.022 times 10 to the 23rd power on top, and then you have the things and the moles on the bottom. And the question is, which fraction do you use? Well, we're starting off with the number 4.5 moles. So you do the same thing here. I want the moles on the bottom and the associated helium atoms up on top. I'm just going to put He atoms. And essentially all you got to do is multiply 4.5 times 6.022 times 10 to the 23rd. Now, my favorite part about this is moles will cancel out with moles, and I'm always going to take that step because it's my favorite step, and it also really makes sure that I am doing the right steps. And when I calculate this out, this becomes 2.7 2.7 times 10 to the 24th power? Yep, 24th power of atoms. That is a lot of atoms.